In Module 8.1, we're going to be solving equations by factoring. And we're going to start by factoring ax squared plus bx plus c. And if you can recall, that is our standard form. So essentially what we're doing is we're starting from standard form. And we'll be factoring so we can have our equations in factored form, hence the name. And a few things to keep in mind when we're factoring in this form, we're going to assume that a is 1, so our a value is going to equal 1. And the goal is to find two factors of c whose sum is b. So again, we're taking our b value and we want to find those two factors whose sum is b, but when you multiply them together, they give you c. So let's take a look at this first one right here that we have. It's a quadratic equation in standard form. It's x squared plus 9x plus 18. The goal is to find factors of 18 that when we add them together, meaning we take the sum, it equals 9. So let's just go kind of down the list and see what factors we can come up with. And the first one that comes to mind is 1 and 18, because 1 times 18 is 18, but when I add them together, I get a sum of 19, so this one does not work. We'll put an X there. The next factors that I can think of is 2 and 9. 2 times 9 is 18, and when I add them together, I get 11. Nope, that doesn't work because I need to get a sum of 9, so I'll put an X there. There's another one that comes to mind. How about 3 and 6? Yeah, 3 times 6 gives me 18, and when I add them together, I get 9. So that one works out. And the way I'm going to write this, I'm going to write it in this form. So factor form, if you can recall, looked a little something like this. I'm going to write it off to the side, or off onto the side. So if I have, say, x plus m, I'm going to times it by the quantity of x plus a. And we set that equal to 0. So my factors are going to replace my m and n, the m and n values. So since these are the ones I'm going to use, then I can create my quantities that look a little something like this. I'm going to take my 3 and I'm going to substitute that in for m, and I'm going to take my 6 and substitute that in for n. So I get the quantity of x plus 3 times the quantity of x plus 6. Notice I don't set it equal to 0 because in the original expression it's not set equal to 0, and that's fine. So I'm going to leave it like this, and this would be our factored form of the standard expression that was given to us. Let's take a look at another example. So we want to factor x squared plus 13x minus 30. Again, I want to find factors of my c, which is negative 30, whose sum is positive 13, which is my b. Let's go ahead and go down the list. See, let's do negative 3 and positive 10. Yeah, negative 3 times 10 gives me negative 30, but when I add them together, that gives me 7. Nope, that doesn't work. Put it next to that. How about negative 5 and positive 6? Okay, negative 5 times 6 is negative 30, but when I add them together, I get 1. That doesn't work. Oops. Okay, oh, sorry, it's glitching. Okay, there we go. Let's find another one. How about negative 30 and 1? Okay, negative 30 times 1 is negative 30, but when I add them together, I get negative 29. So just bear with me through this process because I want to show you that sometimes it takes a little bit of, kind of guessing and checking and just experimenting in a sense. The last option that I'm going to play around with, because I know this one is correct, is negative 2 times positive 15. That gives me negative 30. And when I add them together, I get positive 13. That in fact works. So I'm going to use these as my factors to write it in factored form. So I can essentially write it as x minus 2 now, since I'm dealing with a negative 2, times the quantity of x plus 15. And that would be my factored expression from the expression that was written in standard form. All right, so now let's go ahead and start solving equations by factoring. At first, we were just practicing our factoring. Now we're going to solve equations by factoring. And if you could recall, what that refers to is essentially just finding the x-intercepts. So what I'm going to do is, this is not in standard form right now, so I'm going to rewrite it in standard form by moving the 12 over to one side of the equation, so the other side equals 0. So I have x squared minus 8x plus 12 equals 0. There we go. So we have one side that equals 0. And remember, I'm trying to find x values to make this side equal to 0. I'm going to show you, instead of what we did earlier, creating this list, going through the list, I'm going to show you the x method, which a lot of you probably have experience with. So essentially what that method refers to is, if I have, say, my x right here, and I am trying to find, actually let's do it in a different color. So keep it as white for right now. I'm trying to find the product of my a times my c, but in this case, my a is going to be 1. So essentially I'm going to take my c and I'm going to put my b down here. And I'm going to try to find an m value and an n value that when I multiply them together gives me my a times c up top. But when I add them together, it gives me my b down below. So again, I'm trying to find the m and m, thinking of multiplication up here and addition down below. What comes to mind right away is the values of, let's say, negative 2. Oops, let's go back to white. Sorry, before I even do that, I have to fill in my c value. My c value up here is 12. And my b value down here is negative 8. And I know that if I do negative 2 times negative 6, that gives me 12. And when I add negative 2 to negative 6, that gives me negative 8. So with that, I can now write my factors as x minus 2 times the quantity of x minus 6. And I can set that equal to 0. And we've practiced this using the zero product property, where I can just identify my x-intercepts right away. But if you forgot, what we can do now is set x minus 2 equal to 0 and x minus 6 equal to 0 and solve for x. And I can do that by adding 2 to both sides over here, adding 6 to both sides over here, and I'm left with x equals 2 and x equals 6. And that would be my solution for this quadratic equation. And to walk back these steps, remember, we rewrote it in standard form. Looking at this, it's very difficult to identify the x-intercepts. So what we did was we rewrote it in factored form using the x method. And then right away, we can identify our x-intercepts. All right, everything's moving around. Okay, let's take a look at our last example. X squared minus 2x equals 15. Again, we want to do what we did earlier, and we want to solve by factoring, and we'll use the x method to do so. So let's go ahead and start that process. But first, I want to get this in standard form, get 0 on one side. So I need to move this 15 over to the left side. So I can do that by subtracting 15 to both sides, and I get x squared minus 2x minus 15 equals 0. And I'm just going to write this out that my b is negative 2 and my c is negative 15. Using that x method, I know that I put my a times c up top. Well, 1 times negative 15 is going to be negative 15. And then I put my b down below. That's negative 2. And now I have to come up with two factors of negative 15 whose sum equals negative 2. So playing around with it, some might say negative 3. And so, I'm not going to write it out, but some might say negative 3 and positive 5. But the problem is that would give you positive 2. So make sure it is, in fact, negative 5 and positive 3. Negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. And, I know I'm doing this rather quickly, but, when you approach a problem like this, it's going to take, some time to plug in numbers and check to see if they are, in fact, the correct factors. Okay, so since this works, keep this in purple, I'll do the quantity of x minus 5 since it's negative 5, and I'll do the quantity of x plus 3 since it's positive 3. Remember that equals to 0 because we are finding solutions. Right away, I know that x equals 5 because the value of 5 here will make this entire thing 0. And then I know that x equals negative 3 because the value of x here, if it was negative 3, will make this entire quantity 0. Therefore, those are my solutions. Those are my x-intercepts, and those are my zeros.